Okay, so we're going to talk about the quadratic formula. So before we really get into the quadratic formula, I want you to think about what it means to be a quadratic. So quadratic has this term that has this exponent of 2 on it. So this is the standard form of a quadratic. So we have, and the a, the b, and the c, those are just coefficients in front of those variables, okay? So if I had something like 2x squared minus 5x plus 3, here my a is 2, my b is negative 5, that sign is going to go with it, and the c is 3. So it's important that you be able to recognize these variables because we're going to use them to plug into the quadratic formula and actually solve. So far in Algebra 2, you've learned a lot of ways to solve quadratics. We've factored and solved, we've completed the square, we've graphed and found the x-intercepts. So the quadratic formula is just a way that it's kind of a fail-safe. It always works with any quadratic, but there's a couple of things that have to happen first. So I want you to think about this for just a minute. So before you use the quadratic formula, you need to make sure of a couple of things. And I'm just going to do cute formula here. Save myself a few letters. All right, the first thing is it must equal 0, okay? Every time it's got to equal 0. So if I have 5x squared plus 3x equals 2x minus 4. Well, what I have to do is I've got to get everything on the same side because this only works when it equals 0. So I'm going to, just out of habit, I'm going to leave my leading coefficient, my squared term there, positive. So I'm going to move the 2x, remember it's an equation, so we got to do it to both sides. And I'm going to move the 4, and I'm just going to go ahead and do them all at one time. So now I have 5x squared. 3x minus 2x is positive 1x plus 4. So now it equals 0, okay? So before I use that quadratic formula, I need to make sure it equals 0. And I also need to identify a, b, and c. And those are those coefficients, okay? So in any order that you see it written, okay, if this had been x plus 5x squared plus 4, you need to be able to tell a is the number in front of x squared, b is the number in front of x, and c is the constant. So here, a would be 5, b would be 1, and c would be 4. So now I'm ready to use this quadratic formula, okay? So make sure these two things happen before you start the quadratic formula. Okay, so the quadratic formula is a plug and chug kind of thing. It tells us, remember, it's solving for x, and x are my x-intercepts as well. So I'm going to do opposite b. Notice I don't say negative b, I say opposite b, because if it's negative to start with, it's going to change the sign. Plus or minus the square root of b squared minus 4ac, okay? This is all under that radical, so keep it together. And everything over, so opposite b plus minus square root of b squared minus 4ac all over 2a. So it's important that you realize that this 2a goes to this entire expression here on top. Okay, so you do the entire top first. So a good rule of thumb is do what's under the radical first. Okay, start there. Then do the whole top. And then the very last thing you want to do is divide by the 2a. Okay, so you want to remember to go in the right order of operations here. All right, so let's do an example real quick. Let's say I have 2x squared minus 3x plus 1 equals 0. So order equals 0, I'm good to go. My a here is 2, b is negative 3, and c is 1. So I want to do, remembering that formula, opposite b, so it's going to be positive 3, plus or minus the square root of. I've got b squared, should be a negative there, minus 4 times a times c. Everybody goes over 2a. Okay, so remember, let's do the radical first. Negative 3 squared is 9. 4 times 2 is 8. Times 1 is 8 still, over 4. Okay, so now I have 3 plus or minus the square root of 1 over 4. So remember, I want to simplify the top of that first. We all know that the square root of 1 is just 1. Now if you get to this point and this doesn't simplify, let's say that was the square root of 2, okay, then you would leave the square root of 2 in your answer. But here, because this does simplify nicely for us, this gives me 2 solutions. So it gives me, and I think I'll go to the next page to show you, 3 plus 1 divided by 4, and it also gives me 3 minus 1 divided by 4 because I can split those up. 3 plus 1 is 4, 4 over 4 is 1, so there's one solution, and then 3 minus 1 would be 2 over 4, which is 1/2. So what this is telling me is I have this parabola, and even if I know nothing else about it at this point, I know that at 1 and 1/2, this is where it's crossing the x-axis. These are the intercepts there, okay? So my 2 solutions are here. Now, quickly, let me talk about the discriminant. The discriminant is that little part that's under the, if I can spell it right, the radical, b squared minus 4ac. And if you think about what a radical, the properties of a radical, okay, if I get a positive number here, okay, so if b squared minus 4ac is positive, that tells me, just like it was in the example we just did, that there are 2 real solutions. Okay, so we had positive 1 on ours. Positive 1 gives me 2 real solutions, and I did get 2 real solutions there. I got 1 and 1/2. Okay, so now let's see, what if I got a negative number under that radical? Well, we know that negative under a radical gives me imaginary solutions. So I would have 2 imaginary solutions. And I want you to think about what that looks like on a graph. That means it doesn't cross on our real number plane here. So maybe the parabola sits above the axis or even below the axis, but it never crosses that axis, okay? One other scenario is if you get 0. 0 means that it only has 1 solution. And that one real solution, if you think about a parabola, the only way you can get one solution, or you can get it to cross only one time, is if that vertex sits right on the axis, so that's the only place it touches, okay? So if you just plug in this, if you get positive, 2 real, negative, 2 imaginary, 0 is 1 real solution.